Hello, everyone. I'm going to present my final project in advanced programming class about the analyzing electric vehicle charging station, usage patterns, and machine learning approach incorporating weather and COVID-19 impacts in Boulder, Colorado. My name is Mashid, and I'm a master's student in civil engineering at UTC. And also, I'm working as a graduate research assistant at CUIP and working on object detection. So, why have I chosen this topic? The topic addresses the need for the sustainable energy solutions by analyzing electric vehicle charging stations. It, it incorporates localized factors like weather and COVID-19 impacts in Boulder, Colorado to provide relevant insights. The study reflects an interdisciplinary approach combining technology and sustainability to solve real-world challenges. So why do we need to analyze EV data? Because growing EV adoption and infrastructure challenges, research and analysis studies, charging station economics, types of EV chargers, and charger selection factors. Data. So why I chose Colorado? Because I tried to look online and I found it from the Kaggle and it was real like data. I know it's not a lot of data, but it's real. For other data I had to pay. That's why I tried not to do it. So that's the distribution of EV data dashboard. So from the first picture, EV data for Boulder City in Colorado State, it shows us almost 147,000 sessions. And also it shows us the number of sessions by year, and also it shows us by number of sessions by month. And number of unique charging stations by year. So that's this is the only data we have. And I try to put it in this way. It's easier to see. So the distribution of EV data dashboard. So the distribution of total duration hours, like how many hours, and also the distribution of total charging duration hours. So when the car comes to the charging station for charging, so at first we have a start charging, end charging, and also when they're leaving. So that's the parking also we have to calculate, we have to consider. So another exploring EVs charging station data. So we have the number of sessions by month and year together, and we can see, like for example, from 2021, because of the COVID, we can see we have less sessions because of the COVID. So when lockdown happened, so a lot of like things went down. So we can see from the 2021, actually from to end of the almost from the April 2020, we can see is very light color, and it's going a little to almost August, September, and also October. We can see that. And then from the June 2021, we see is growing. And you can see on 2022 and 2023, we have a lot of sessions. So the other one is distribution of charging session for each month. And you based on like, I guess the best example is 2020 because it was very less sessions. So you can see it's a little is let down. And then after from 2021 is growing. And from 2023, it's a lot of charging sessions happen. And those are the top 15 high demand charging stations in the city of Boulder in Colorado. Okay, so the second data, exploring the Colorado weather data. So based on the graph, we can see, so when the temperature is going, the temperature was going down, so we had less sessions, and when the temperature is up, we have more sessions. That's the graph it shows us, and also the precipitation and snowfall over time. It shows us another graph. So the third data is exploring Colorado COVID data. So from 2020 is March 2020, we can see is less. And then when it's going up from like May to July and also September, it's little straight. And then after that, it's going up. That's the COVID deaths over time. The methodology, data pre-processing, data cleaning, and also machine learning. So why data pre-processing? And what is data cleaning? So data cleaning also refers like if we have any missing data or non-value data, and also any irrelevant value like zero charging time. That's what we're doing. We're doing it for data cleaning. And the challenging is finding relevant data for Colorado, and also the old data together with data column and primary data challenge and time zone complexity, and finding factors make effect on charging sessions utilization. And also we use the random forest. How random forest works? Random forest is an assembled learning method that operates by constructing multiple decision trees and aggregating their predictions to generate more accurate and stable results. So now we're going to work on an experiment. So the charging station utilization prediction, COVID, and effect on EVs utilizations. So this is the experiment. So based on this graph, we can see the correlation heat map. So this correlation heat map visually represents the relationship between different variables in a data set. So it's going to work from the value range from -1 to 1, and 1 stands for perfect positive, 0 is no correlations, and -1 is perfect negative correlations. And you can see it here. So this model performance is a random forest model achieve R squared of 0.231. That's the validation, and 0.222 is the test. So the color gradient is dark blue represent the strong negative correlations, and then light blue or also whatever close to white represent weaker, no correlation, and the yellow represent a strong positive correlation. So the correlation analysis is a strong correlation is 0.9 between max temp and minimum temp. We could say it in that heat map. And then is weekday and is weekend perfect negative correlation is -1. And then precipitation and snowfall moderate positive correlation indicating some association is almost 0.42. And normalized even count and peak hour is almost close to 0.47, is suggesting events are more frequent during peak hours. And then the energy weak correlations with most variables, implying no strong relationship with weather or time related factors. This from that chart, we can identify which variables are strongly or weakly related, guiding feeder selection or analysis in tasks like machine learning or statistical modeling. So COVID and effect on EVs utilization. So during the pre-pandemic period, it was almost 1,500 to 2,000 charging sessions per month. But when the pandemic happened, sharp decline to 500 to 1,000 sessions per month. And then the recovery and growth phase between 2021 to 2023, starting from the middle of 2021, it increased to 3,000 to 4,000 by 2022. So seasonal patterns consider higher utilization during summer times, like May to August, probably because of some traveling during the summertime, and also lower usage in winter months. And also we have the key finding COVID-19's impact on charging station usage. It was just temporary. So anything happens usually is temporary. We can after that we could see the growing. So this is the COVID and effect on EV's utilization. And this is the graph. It shows us the red color shows us the cumulative COVID-19 deaths. So exactly, it shows us from the 2020 around June to June 2021, it was the charging session, it was down. And then after that, it grew. So the carrier relevance. So it's problem solving, using machine learning, writing a paper, how to face with challenges, organizing a project, and also finding data. So in conclusion, one of those keys finding, analyze Boulder, Colorado charging data from 2018 to 2023. And I used a random forest model, achieve R square of 0.231. And temporal patterns were more influential than environmental factors. And also clear seasonal variation with summer peaks and winter low. We had three distinct phases identified: the pre-pandemic stability and sharp decline during the initial lockdowns, and also a strong recovery exceeding pre-pandemic levels by 2022. And monthly session grew from 2,000 pre-pandemic to over 5,000 by 2023. The model performance and limitations. The model predictive power indicates presence of unobserved influences, suggesting charging behavior is affected by factors beyond current dataset. And future research needs geographical coverage will benefit from including demographic data and also local points of interest. And also we have the research implication. Finding can guide charging infrastructure planning, and also shows a strong EV adoption grows despite disruptions and contributes to sustainable urban transportation development. Thank you so much for your energy and listening to my presentation. Thank you.